let's look at periodicity of properties of period 3 elements. When we talk about periodicity of properties of period 3 element, we are referring to changes in the properties of this element as atomic numbers increase. When you look at period 3, you see elements like sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So starting from sodium, whose atomic number is 11, you end at argon, whose atomic number is 18. As the atomic number increase, so is their property changing. Sodium is an alkaline metal. Magnesium is an alkaline earth metal. So magnesium is less reactive than sodium. After magnesium, you see aluminum, which is called a soft metal. After aluminum, you see silicon. Silicon is a metalloid. That is, its property lies between that of metals and non-metals. After silicon, you have phosphorus, which is a non-metal. Beyond phosphorus, you see sulfur. Sulfur is also a non-metal. And then you see chlorine after sulfur. Chlorine is a non-metal. Their non-metallic character increase from phosphorus to sulfur to chlorine. And you end in argon. Argon is a non-reactive element. You cannot say that argon is a metal. You cannot say that it is a non-metal. It is called a noble element, a noble gas. Now, looking at some of the properties that shows periodicity, let's take atomic radius. I mean the atomic radius of period 3 elements. As you move from left to right, that is, as their atomic numbers increase, their atomic radii decrease. Why? The reason for reduction in atomic radii as you move from left to right is because of increasing electrostatic force between the nucleus and the electrons. So, as the atomic numbers increase, the pulling force between the proton and the electron increase, thereby pulling the electron closer to the nucleus. And when that happens, the atomic radius of the element next to 1 will be less. Let me put it this way. Let's take magnesium and aluminum. The atomic number of magnesium is 12, while that of aluminum is 13. So, we expect that the atomic radius of aluminium will be less than that of magnesium, because the electrostatic force between the nucleus and the electron in aluminium is higher than that of magnesium, thereby moving the electron closer to the nucleus. So the electrons are closer to the nucleus in aluminium than it is in magnesium. The second property we shall consider with respect to this period 3 element is electronegativity. Electronegativity is simply the power of an atom, to attract electrons. So, electronegativity increases from left to right. What this means is that chlorine is more electronegative than silicon. Silicon is more electronegative than sulfur. Chlorine is more electronegative than sulfur. Sulfur is more electronegative than phosphorus. Phosphorus is more electronegative than silicon. Third, we look at their structure and the bonding tendency. Structure and bonding tendency. When you look at sodium, magnesium, and aluminium, they are involved in metallic bonding, while the non-metals among them are involved in covalent bonding. The last one, argon, is not involved in bonding. It's an inert element, a noble gas. So there is what is called gradation from metallic to covalent to inert. Next is their oxides. These period 3 elements, what is the nature of their oxides? An oxide is a compound formed when an element reacts with oxygen. That is, an oxide is a compound formed, in fact, it's a binary compound of oxygen. That is, oxygen and one more element. Now, when you look at the oxides of sodium and magnesium form basic oxide. Aluminium, silicon form what is called amphoteric oxide. The non-metals among them, phosphorus, sulfur, chlorine, they form acidic oxides. You can see the change in the property of their oxide as you move from left to right along period 3.
Quiz.